If you're taking a class in trigonometry, you won't get very far without realising that some questions require the use of a calculator and some you can do manually without the calculator. So there's a big split in the question types in trigonometry depending on whether they're calculator or non-calculator. So for example, if you wanted to process something like the sine of 75 degrees, there's no easy way to do this without a calculator. So this would just literally have to go straight into the calculator and you would get whatever the value comes out to be. Whereas some values, for example, the sine of 30 degrees, you can process manually without the calculator. So this one comes out to be 1/2, okay, so 1 over 2. So we're going to explore in this class how we can work out these values for the values that we can work them out for. And it turns out that for these, what we're going to call common angles, which are 30 degrees, 45 degrees, and 60 degrees, and multiples of these, although we're not going to chat about multiples of these in this class, we're just going to focus on these ones as like an introduction to this topic. These guys you can work out manually for sine, cosine, and for tangent. So the way that we go about doing this is by the use of what we often call like two special trig triangles, and you've just basically got to memorize these. So the first triangle looks like this. So they're both right angle triangles. So this one is kind of symmetrical. These two side lines should be the same. Maybe not on my diagram, but they should be the same because these two angles are the same. They're 45 degrees. If you're familiar with radians, then this is also true for radians. That could be pi by 4 radians. If you've got no idea what I'm talking about, then fair enough, just stick with degrees. So yeah, this is the first triangle, and we label up the sides for this one. 1, 1, obviously they've got to be the same side length if they're the same angles, and then by Pythagoras, this would work out to be √2. Okay, so we'll just leave that there just now. So that's working with the 45-degree angle. The next triangle is the one that captures the 30 and the 60 degrees, so right angled. It's very tempting to draw this triangle like that one, but it should be a little different because this angle in here is 30, this angle in here is 60, so that angle should be a lot wider than this angle. So I see a lot of students drawing this triangle the same as that one, even though these two angles are, well, this one's double that angle, so the triangle should look nothing like this one really. It's very tempting to draw it the same, but then that can cause a little confusion, so try to get into the habit of drawing it kind of properly-ish. And this one has side lengths 1, 2 on the hypotenuse, and then by Pythagoras that would be √3 down there. These two triangles are really, really powerful, really useful in trigonometry, and if you're doing any trig non-calculator, like manually, you just basically need to know these, so spend some time trying to commit these to memory. Okay, cool, right, so what can we actually do with this? So how did I get the sine of 30 equals 1/2? Well, turn into this triangle down here. If we're working with 30 degrees, just using SOHCAHTOA, we could label this triangle up with 30 degrees as our reference angle. This would be opposite, this would be adjacent, and this would be hypotenuse. Sine is opposite over hypotenuse, so just a reminder from SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and then tan opposite over adjacent. So we're going to do opposite over hypotenuse 1 over 2. So that's how we know the sine of 30 is 1 over 2. So basically for any of these angles, for any of the trig functions, you can work out the corresponding value. If we wanted to do the cosine of 30 degrees, we would just turn to the same triangle. That's still a reference angle. This time it's going to be adjacent over hypotenuse, which comes out to be √3 over 2. Remember when you're working with SOHCAHTOA, your labels depend upon the angle you're using as your reference angle. So if we wanted to change to the sine of 60 degrees, then we need to relabel our diagram because now this is our reference angle, which means that this is no longer adjacent, this is now opposite, this one is adjacent. The hypotenuse never changes because that's just the long side of the triangle. So if we wanted to work out the sine of 60, then we're going opposite over hypotenuse, so that comes out to be √3 over 2. If we wanted to work out the cosine of 60, should be really saying the cosine of 60 degrees, but we often just forget the degrees, but cosine of 60 degrees, remember these are always acting upon angles. So cosine of 60 adjacent over hypotenuse for cosine, 1 over 2, so 1/2. Just going to pull down the result I had up here, which is that the sine of 30 degrees is also 1/2. So notice that these guys are kind of paired up, right? So we've got the same result there. One is for cosine of 30, sine of 60, and then the same kind of thing going on here. That is always useful to remember that that kind of pattern exists. If we turn to the other triangle and we do, let's say, the sine of 45, doesn't matter which one you choose as your reference angle here because they're both the same. So if we choose that one, then this would be opposite, this would be adjacent, and that would be hypotenuse. Sine would be opposite over hypotenuse, 1 over root 2. So the sine of 45 is 1 over root 2. Because the numbers are the same, because the triangle is kind of symmetrical, then it would mean that the cosine, which is adjacent over hypotenuse, is also for 45 degrees going to be 1 over root 2. So in addition to being able to work these out manually every time from the triangles, which is a really important skill, especially when we come to do multiples of these, it's also just useful to try and recognize the patterns in there and ideally to memorize these values, okay? If you see trig questions which have got these numbers in them, so basically the numbers are on the sides of the triangle, for example, a trig equation which has got a 1 and a root 3 and a 2 or something like that in it, that's probably an indication that you have to perform the calculation manually. I mean, you would know anyway because it should be either a calculator or a non-calculator question, but that would be validation that that would be the case. Opposite to that, if this was a number like a 4 and this was like a root 7, then that can no longer be done manually, so that would need to be a calculator question. So I focused there on sine and cosine. Tan works as well, so it doesn't really matter which of the functions you're using if you wanted to do the tan of 30. Tan's a little bit different because it doesn't have a pattern in the same way the sine and the cosine does. It's kind of out there on its own. So for tan of 30, we're going back down to this triangle. We're relabeling it to make 30 our reference angle, and therefore this is opposite and this is adjacent. Tan is opposite over adjacent from SOHCAHTOA. Opposite over adjacent is going to be 1 over root 3. So, quick recap to get the key points from this class. If you're working trig with a calculator, you can just fire the values in the calculator, for example this one. If you're working trig with what I've called the common angles, which are 30, 45 and 60 degrees, then you've got the opportunity to use these triangles and work them out manually. The ideal scenario would be if you can use the triangles, know the triangles, but also kind of learn these values. If nothing else, that's going to allow you to calculate more quickly, which is just always a good thing. This class has only included the angles 30, 45 and 60. We'll see in a subsequent class how to work out multiples of those angles. It's not as easy, unfortunately, as just multiplying the answer. There's a different method that we need to go through for that. Just to quickly mention as well, some of the other values you might want to know would be 0 and 90, and then other values beyond that potentially as well. I call those extreme values. So for example, if you take the sine function, which has got a graph like this, if you want to know 0 and 90, so this is 0 here, and then 90 is here. If you want to know the value of the function at those points, so in other words, if you want to know the sine of 0 and the sine of 90, we can't use the triangles for those because 0 and 90 are not angles. Well, the 90 is an angle in the triangle, but basically don't use them. Only use the triangles for 30, 45 and 60. Use the graph for these extreme values. So the sine of 0 is 0. In other words, if you go 0 along the way, your up and down value is 0. The sine of 90, if you go along 90, you're at the highest point on the graph, which is 1. Okay, so the sine of 90 is 1. So all of the multiples of 90 degrees, 0, 90, 180, 270, which is that point there, and then the last point, 360, all of these multiples you're better to take off the graph of sine, cos and tan. The method of using the triangles here kind of breaks down. This is a really important topic because if you're going to do trigonometry non-calculator, which is quite often what you're going to be tested on, because it's kind of too easy just to fire it in the calculator, If you're going to be tested on this, you're going to need to know this stuff. This is fundamental knowledge for a lot of trig questions, so not being able to do this is probably going to be a bit of a roadblock, but it's not easy at first. There's quite a lot to remember there, quite a lot of process, but it is essentially just SOHCAHTOA and then knowing these triangles, trying to commit these to memory.